hands in the air if you's a true player. I love it when you call me Big Pop, when you call me Big Pop. Throw your hands in the air if you's a true.
Question number 11. X minus 1 divided by 2 minus 1 divided by x is greater than 4 by x plus 5. And name this inequality as inequality number 1. Note that this inequality is not defined at x is equal to 0, because when you will substitute x is equal to 0 here, this expression becomes infinity, and this also becomes infinity. Therefore this inequality is not defined at x is equal to 0, and we will write that x is equal to 0 is a free boundary. This is a free boundary point to the solution region. Now we will do the same procedure as we did in question number 6, 7, 8, 9 and 10. That is, we will associate an equation to this inequality, which is associated equation to inequality 1 is, the associated equation is x minus 1 divided by 2 minus 1 divided by x is equal to 4 divided by x plus 5. Simplify this side, you will get x multiply x minus 1 divided by 1 multiplied by 2 divided by 2x. Similarly, we will take LCM here, x 4 plus 5x. In the next step, x is simply cancelled by this one, and this 2 is multiplied here. You get x square minus x minus 2 is equal to 8 plus 10x. Take these two terms here, you will get x square minus 11x minus 2 and minus 8 minus 10 is equal to 0. Now you will have to apply the quadratic formula here. You will get x is equal to minus b plus minus square root b square minus 4a and c divided by 2a. And by solving this, you will get 11 plus minus square root, this is 121 plus 121, and this is plus 40. This is equal to 161 divided by 2. So from here you have obtained two of the boundaries. One is x is equal to 11 plus square root 161 divided by 2, and the other is 11 minus 161 square root whole divided by 2. This one on solving on calculator, this is equivalent to about 11.84, and this is equivalent to minus 0.84. Now we have three boundary points. Two are proper boundaries, which are 11 plus square root 161 divided by 2. Second one is 11 minus 161 square root divided by 2. And the third one is the free boundary, x is equal to 0. Now we will look at these points on the real number line. This is the real number line. Plus infinity is here and minus infinity is here. 0 is at the origin or center. The first point 11 plus square root 161 divided by 2, that is 11.84, is somewhere here. This is 11 plus square root 161 divided by 2, and minus 11 and 11 minus square root 161 divided by 2, that is minus 0.84. It is somewhere to the left of 0 and very close to it. 11 minus square root 161 divided by 2. Now we have four regions. First region is from infinity to this point. This is region number A. The second region is from this boundary point to this free boundary. This is region B. The third region is from this free boundary to this boundary point, and this is region C. And the fourth one is from this point to the infinity, positive infinity, and this point, and this region is region D. Now we will check all of the regions for the solution. We will test the region A for the solution. The region A starts from minus infinity and it ends at minus 0.84. Therefore, minus 1 is somewhere between these 2 points. So we can take x is equal to minus 1 as the test point, and you will substitute it in your given inequality, that is this one. On substitution, you get minus 1 divided by 2 minus 1 divided by minus 1 is greater than 4 divided by minus 1 plus 5, and this is minus 2 divided by 2 plus 1 is greater than minus 4 plus 5, which is 0 is greater than plus 1. Since 0 is smaller than plus 1, therefore it is false. And the region A is not in the solution. Now we will check out the region B. Region B is from this point to this point, that is from minus 0.84 to 0. This means that a point, we will have to take out a point between these 2 points. For example, we can take x is equal to minus 0.5. Now we will put this x is equal to 0.5 in this inequality, and we will check if it is true or false. X minus 1, that is minus 0.1 minus 1 divided by 2 minus 1 divided by x, that is minus 0.5, is greater than 4 divided by x, that is minus 0.5 plus 5. Minus 0.5 minus 0.1 is minus 1.5 divided by 2, which is minus 0.75, and this is plus 2, and it is greater than minus 8 plus 5. The answer of this one is 1.25, and it is greater than minus 3. Yes, it is true. Therefore, the region B is in the solution. Now we will check out region C. The region C is between x is equal to 0 and this point 11 plus 161 divided by 2. So region B is from 0 to 11.84. One of the points between these 2 points is x is equal to 1, and we can take it as a test point. We will substitute it in the inequality 1 so that we get 1 minus 1 divided by 2 minus 1 divided by 1 is greater than 4 divided by 1 plus 5. And answer to this one is 0 minus 1. This is greater than 4 plus 5. This is minus 1 and this is 9, which is not true, false. Therefore, the region C is also not in the solution region. Now we will seek for the final region, that is region D. And the region D is from this point to infinity, that is 11.84 to infinity. Region D it starts from 11.84 and it ends at positive infinity, that is, it never ends. One of the points is, for example, x is equal to 15. This is test point, and you will substitute it into your inequality. You will get 15 minus 1 divided by 2 minus 1 divided by 15 is greater than 4 divided by 15 plus 5. When you will solve it out, you will get 104 divided by 15 is greater than 79 divided by 15, which is obviously true. So region D is also the solution region. So in the solution we have two regions. One is from this point to this, that is the region B, and the region D. The region B starts from 11 minus 161 square root divided by 2 to 0, while the region D starts from 11 plus square root 161 divided by 2 to infinity. Therefore, we will write that the solution set is, it starts from this point, and this point is not included in the solution region. 11 minus square root 161 divided by 2 to 0, and 0 is free boundary, therefore it is not included in the solution. Union the region D. The region D starts from 11 plus 161 square root divided by 2 up to infinity, and it is not included in the solution. Question number 12. Absolute value of x square minus x plus 1 is greater than 1. Absolute value of x square minus x plus 1 is greater than 1, and name it as inequality number 1. Associated equation is x square minus x plus 1 absolute value is equal to 1, and this is equivalent to x square minus x plus 1 is equal to plus minus 1. So one equation is x square minus x plus 1 is equal to 1, and the other is x square minus x plus 1 is equal to minus 1. On solving this plus 1 is cancelled by this negative 1. You get x square minus x is equal to 0, and take x common from here, x minus 1 is equal to 0, and therefore the boundary points from this this equation are x is equal to 0 and x minus 1 is equal to 0, that is x is equal to 1. So these 2 points are the boundary points. Next we will solve this equation, and this is x square minus x plus 1, and this one comes here plus 1, and we get x is equal to 0. X square minus x plus 2 is equal to 0. Next we will apply the quadratic formula here, and by applying that formula we get x is equal to minus b, that is 1, plus minus square root b square, that is 1, minus 4ac 4ac divide by 2. And note that you will obtain x is equal to 1 plus minus square root minus 7 and whole divide by 2. This is equal to 1 plus minus square root 7 iota divide by 2. Since these two answers are the complex numbers, and complex numbers cannot be drawn on the real line, therefore we cannot take these points as the boundary on the real lines. Therefore these two are simply discarded. So we have only two boundary points, that are x is equal to 0 and x is equal to 1. X is equal to 0 is the boundary point, and x is equal to 1 is also a boundary point. This is region A from minus infinity to 0, and this is region B from 0 to 1, and this is region C from 1 to infinity. Region A. A point in this region is x is equal to minus 1. You will test this point into your inequality. Your inequality is x square minus x plus 1, absolute value is greater than 1. X square, that is 1, minus x square minus x plus 1, absolute value is greater than 1. Solve it. 1 plus 1 plus 1 is greater than 1. This is true. Therefore the region A is in the solution. Now you will check region B. Region B is from 0 to 1, so one of the points is x is equal to 0.5. You will get 0.5 whole square minus 0.5 plus 1. It is greater than 1, and this comes out to be equal to 0.75, absolute value greater than 1, and this is false. The final region is from 1 to infinity, therefore x is equal to 2 is the test point in region C. Test. So you will get 2 square minus 2 plus 1 is greater than 1. 2 square minus 2 is equal to 4 minus 2 1, sorry 2 plus 1, that is 3. Absolute value of 3 is greater than 1, and yes, it is also true. So two regions are in the solution, that is region A and region B. Therefore the answer is solution set the first region A, minus infinity to 0, minus infinity to 0, and 0 is boundary, therefore it is not included. Union, the region C, that is from 1 to positive infinity. 1 is the boundary, it is not included, and infinity is not the real number. This is the answer of our question. Next question is question number 13, and it is quite similar to question number 11. X raised to the power minus 2 minus 4, x raised to the power minus 1 plus 4 is greater than 0. This can also be written as 1 by x square minus 4 divided by x plus 4 is greater than 0. And note that this inequality is not defined at x is equal to 0, therefore x is equal to 0 is a free boundary. Now we will simplify this equation. LCM is x square, and you would get 1 minus 4x plus 4x square is greater than 0. You will have to associate an equation. The associated equation is 1 minus 4x plus 4x square divided by x square is equal to 0. This is your associated equation. And from here you will get, by multiplying both sides by x square, 1 minus 4x plus 4x square is equal to 0. And you will have to make use of quadratic formula to solve this equation, and you will get x is equal to 1 by 2 and 1 by 2. Since this point has to be included in the solution set, therefore we will get only 1 point. X is equal to 1 by 2. So boundary point is only 1, that is 1 by 2. We cannot say that we have two boundary points. One is 1 by 2 and other is 1 by 2. These are same points. These two numbers are same, therefore we have only 1 point, and that is 1 by 2 as the boundary point. Also, we have the free boundary, that is x is equal to 0. Question number 15 is x to the raised to the power 4 minus 5x cubed minus 4x square plus 20x is less than or equal to 0. Name this inequality as inequality number 1 and associate an equation to this inequality, that is associated equation is x power 4 minus 5x cubed minus 4x square plus 20x is equal to 0. This is equation number 2. You will have to solve it. Take x as common between them. X cubed minus 5x square minus 4x plus 20 is equal to 0. You will get x is equal to 0 and x cubed minus 5x square minus 4x plus 20 is equal to 0. This is one of the boundary points. You can take x as common between first two. X square can be taken as common. X minus 5 minus 4 is taken as common. You will get x minus 5 is equal to 0, and x minus 5 is again taken as common. You will get x square minus 4 is equal to 0, and from here x minus 5 is equal to 0, x square minus 4 is equal to 0, x is equal to 5, and x minus 2, x plus 2 is equal to 0. you will get x is equal to 2 and minus 2. Thus you have the boundary points x is equal to 0, 2, minus 2 and 5. These are all the boundary points. You will locate them on the set of real numbers, that is the real number line, plus infinity here, minus infinity here, origin O, that is 0 here. 0 is the boundary point, and 2, minus 2, these are also the boundary points, and the fourth one is positive 5. So the regions are region A from minus infinity to 2. This is region A, and region B is from minus 2 to 0. Region C is from 0 to positive 2. This is C. Region D is from 2 to 5, and region E is from 5 to positive infinity. Now we will check all of the region for the solution. Region A, obviously one of the points in the region A is x is equal to minus 3. You will test x is equal to minus 3 and you will put it into your inequality number 1. After putting it into that inequality, this inequality is not satisfied and it is false. Similarly, we will check out region B. One of the points in region B is x is equal to minus 1, and upon substituting this x is equal to minus 1 into your inequality, you will get it as true. Now we will test out the region C. This is from 0 to 2, and one of the points in this region is x is equal to 1. You will substitute x is equal to 1 into your inequality, and this proves to be wrong, that is false. And then region D, one of the test points in this region is x is equal to 3. As can be seen, it is from 2 to 5, therefore x is equal to 3 is in this interval, and upon substituting it into your inequality, it proves to be true. And region E has a test point. For example, x is equal to 6, and when you will put this x is equal to 6 into your inequality, it again comes true. Therefore, we have 3 regions coming true. One is region number B, the second one is D, and the third one is E. Note that your inequality has the symbol of equality. Therefore, all of these boundary points are included in the solution. The first region is region B, and it is from minus 2 to 0, and since minus 2 and 0 are included, therefore we will make the use of interval minus 2 is included and 0 is also included, therefore it is a closed interval. Next region was the region D. The region D is from 2 to 5, and 2 and 5 are also the boundary points and they are included, 2 to 5. And the third one is region E, that is from positive 5 to positive infinity, and positive infinity is not the member of real numbers, and 5 is included, 5, and positive infinity is not included, therefore it will kept open from here. This is the solution that you required. Question number 16. The cost function c of x and the revenue function r of x for producing x units of a certain product are given by c of x is equal to this one and r of x is equal to this one. You have to find out those values of x that will give you a profit. If you are seeking for profit, your revenue must be greater than your cost. It is obvious that if you have smaller cost and you are getting a greater revenue, it means that you're at profit. You're getting a profit. Upon substituting their value, you get 50 minus x squared, which is greater than 5x plus 350. After solving this inequality, after simplifying this inequality, you will get x squared minus 45x plus 350, this inequality, and rewriting this inequality you will get x squared minus 45x plus 350, which is less than 0. You will associate an equation to it, x squared minus 45, name this inequality as inequality 1, associate an equation to it, solve this inequality, you will get x is equal to 10 and x is equal to 35. So these two are the boundary points of your solution region. This is 0, this is 10, and somewhere here it is 35, here plus infinity and here negative infinity. So region A is from negative infinity to 10, this is region A, and region B is from 10 to 35, this is region B, and C is from 35 to infinity, this is region C. You will test the region A to qualify as a solution region. One of the test point in this region is obviously x is equal to 0, and when you will set it into your inequality, that is inequality number 1, you will get a false result. Therefore this region is not included in the solution. Similarly, region B has a test point, for example x is equal to 15, and when you will substitute this into your inequality, you will get a true result. Finally, at region C, one of the test points is, for example, x is equal to 40, and upon substituting it into your inequality 1, the result is not true. Therefore, the only one region qualifies for the solution region, for being a solution region, that is region B. Therefore, the solution is the region B 10 to 20 35. Since 10 is not included in the region in the solution because there is only less than symbol, no equation symbol, so the solution is only region B that starts from 10 and ends at 35, and it is kept open. So all those values which lie between 10 and 35, all those values of x that lie between 10 and 35 are those values that will yield a profit, and that was the required result.